All right. Now, this week, we're going to finish up the overcurrent protection devices, and then we're going straight into doing the full residential calculations. And what we're
Ooh.
going to do, we're going to set up and we're going to go through all the different things we're going to look at. We're going to set it up for 6 groups. Okay.
Okay.
And I'm going to go through the 6 groups. And then when we come back next week, then I'm gonna break them down because they won't show up great on full screen. But we're gonna go through and we're gonna do full calculations, and
All
then
right.
I'll break up the the forms and everything for everybody to see that they can go through and fill this out and learn how to do it. And we'll after we get through that, then we'll get into commercial, and you know, we're going to be close to 12 weeks. You know, it's going to be a little longer than 12 weeks, but you know, I mean, we're going basically 3.5 months of just nothing but calculations, prepping you for the Journeyman and Master. So there was a lot. You know, I tried to do it in 12 weeks, but that's really pushing it. You know, so
So I have a really cool story about the residential service calc. So when I went and took my exam, I remember there was one question that I had on there, and it stuck out in my mind. Well, I started looking at all the equipment they had in there,
mhm.
and I was going through, okay, a 1 kW cooktop, 1 kW range, all this stuff, and just had this whole page of stuff on there. And I says, you know what? Yeah, just put a 200 in there, you know. Well, we went and we worked. I don't know exactly how somebody else had actually gotten the question, kind of the same style, and I actually got to work it. And I know for a fact I passed my journeyman's test, but I know for a fact I got that question wrong because I said I just put a 200 in there. Well, we went and we worked a problem service calc similar to that one where it was just this full page of equipment, and it was, I remember it was a 1 kW cooktop, 1 kW range top, you know, and all that stuff. And we worked the calculation, came out to 124 amps. So I actually got that one wrong. I said, well, there's just a lot of stuff, so you should just throw a 200 at it. Well, that's what a lot of electricians tend to do. Like in that situation, they think, well, it's not going to matter if you're a little bit over, you know, but it matters on that test. It matters on the exam. So that's why we're trying to, you know, get it to where you get the right answer. You don't just give them extra just because, you know, because like you were saying before, now all of a sudden you have a more expensive breaker, you have more expensive wire, you have more expensive everything, and you're better off trying to get that service. If that's all they need is 125 amp, give 125 amp. The code doesn't require you to have future expansion, you know, in
No, it doesn't.
90.2.
And what everybody's going to see, it's very simple to do. I'm going to show you
Right.
how to do it all. As long as you know the process and you realize, I just need to remember these 6 groups. And once you have that set up, ain't nothing after that. So,
Yep.
but we'll get into it. It's going to be pretty simple, really. So, where we left off last week on the homework was dealing with the phase converter. And I said, you need to go over and look at 455.7b when you have a fixed load like this. But in that text, it's going to refer you to 455.6a2. And when you go pick that up on your fixed loads, when you're dealing with that conductor, you're going to take it at 250%. And I said, the rule of thumb is this: when you're sizing the overcurrent protection device, any percentage at 125% or less, you go up to the next standard size. Any percentage above that, you're going to drop down to the next standard size. In this case, I said, when you get to transformers, which we did, I said, if you didn't see that superscript 1 up there that gave you permission, said shall be permitted to go up to the next standard size, you could go up or down. I said, just go up to the next standard size. But any other percentage that was in that table, it didn't have that superscript 1 that was above 125%, we
Right.
dropped down. And then I said, and then when you got to phase converters, because you had to protect the conductor, which is going to reference you back to 455.6a2, you have to protect that conductor. Okay? So when you look at this, if we we go over and we look at table 430.26, which is about 230 volts, come down, pick up 25 horsepower. It's going to tell you it has an amperage rating of 68 amps. And then 455.682 is going to tell you take it at 250%, which gives you 170 amps. And the next size above that to protect that conductor is 175 amp overcurrent protection device. So that is the rule of thumb I want you to remember. 125% or less, go up next standard size. 250% or more, or 120 over 125%, drop down the next standard size. The only two times you want to look at this different is in transformers and here at phase converters. Okay. Now, the next one's AC units. This is very, very simple because all we're going to do is we're going to look over at 440.22a. Now, when you go over and you look at that section, it talks about the rating or setting for individual motor compressors. Now, that I think that's exactly how the heading is written too. But when you go over in the 2023, they redid that section. Okay, I know we're doing 2020 here, but I just want to point something out. Now, a lot of times you can go over and look at an AC nameplate, and you'll see it'll have on their hacker breaker rating, and it'll have minimum and maximum size. Okay. Now, this was an argument that was going on some of the groups, and I said, they say there's no such thing as minimum. And I said, but yet the industry does do that. And they said, you show me where that happens. And I just posted 3 pictures of the nameplate rating of an AC unit. And Jeremy Weed, of all people, he come on, he said, the manufacturer can just do whatever they want. I said, you got to be freaking kidding me, dude. I said, that's not possible. Right. I said, when they UL takes and looks at this, they basically, not only they have to look at the UL standards or any other standards, they also look at the NEC. And I said, you can take that amperage that's on here, and you can take and put that percentage on it, and then add your compressor or your condenser motor to it, and I'll guarantee you're going to get the same size. That's how they make these decisions. They do things in compliance also with the National Electrical Code to get that listing and labeling. Sure. And I said, a lot of people do say, even on tests, what is the minimum size inverse time circuit breaker for a motor, and the minimum is a starting point. Right. And, we had this discussion, we were looking at motors, he goes, well, the table says maximum. That is correct. That's the maximum percentage for that table. Okay. Sure. But you got to have a starting point. And, we've had that in our publications for 30 years. And even when NFPA was publishing them, which they probably still would be if the other associations wasn't complaining about them publishing them, they, their staff went through and edited all of our stuff, and nobody changed the calculation. And sure. Instructors, engineers, inspectors, everybody, electricians, contractors, they've been using that same calculation for over 30 years, and now all of a sudden it's wrong. I mean,
just so everyone's understanding what we're talking about, like, let's just say you have one of these HVAC units, and you just decide you want to put a 30 amp overcurrent device on, say, whatever your minimum circuit ampacity is, 40 amps, whatever. So you can do that. That's not a problem. But if that minimum calculation comes down to, like, say, 35 amps, and all of a sudden you get a breaker tripping, then you know that you need to, you can increase that overcurrent device and, stop that, nuisance trip. So that's the reason the minimum is there, so that you can understand. And don't forget, everyone, to smash the like and subscribe to the channel. We're trying to get 1,000 subs by summer. And David Engelhardt already smashed, so
thank you, brother.
Awesome, David. Appreciate you, sir.
Yeah, and that's, like you said, that's why you have a on the hacker breaker rating, the minimum's done at 175% and the maximum's done at 225%. Now, as I was saying, when you get to the 2023 code, now if you go over and read that, they have an exception 1 and exception 2, which reads like what it used to be in 430.52C1 that deals with motors. Okay. So when you look at 440.22A, it says you can take it at 175%. And it says if it won't start, you don't even have to do another calculation. You can go up to the next size. And then exception 2 says if it still won't start due to inrush current, then you can take it at 225%. Okay. Now, if you go over and look at 430.52C1, does it say the same thing? Sure. You've got your percentage that's done per the table, and if it won't start due to inrush current, then now it's 430.52C1A and B instead of exception 1 and 2. And A allows you to go up to the next standard size without doing any further calculation. And then you got B, based on what type of device you're using, there's a maximum percentage there.
Right.
Okay. That's the way we've always explained this. So nice. If I look at this, I've got a compressor here that's 19 amps and a condenser at 1.5. So you have to take one of the largest motors here at 175% per 440.22A. So I take 19 amps at 175%, add the condenser at 1.5, that gives me 34.75 amps. I said you drop down, because when you read that section, what does it say? A protect device having a rated setting, and what's this? Not exceeding 175. If you can't exceed it, that means you do what? Drop down. This is going to be a minimum starting size. So that'd give you a 30 amp overcurrent protection device. Right. Now, if I'm going to size the maximum, it'll be in 440.22A, but if somebody's looking at their 2023, you're going to go down and look at exception 2 for the maximum. So say I was even doing the maximum here. I could just go up to 35 per exception 1 in the 2023 cycle. But here right. I'm going to go up to a maximum. So I'm going to take 19 amps at 225% and then add the 1.5 gives me 44.25 amps. Once again, it says I can't exceed the calculated value here. So I'm going to drop down the next standard size, which is a 40 amp. So right. My minimum's a 30 and my max is a 40.
Right.
Okay. Now, one thing I want to point out here, I've done a ton of calculations so far. That rule of thumb I've taught up to this point. At 125% or less, go up to the next standard size. Anything above that percentage, you drop down, except for transformers where you have a superscript 1 and where you have phase converters for a fixed load and you're protecting the conductor, you go up to next standard size. Everything I've showed you up to this point has held true, hasn't it?
Yeah, and what I think people aren't going to really understand about this too is you can't really see what's going on with the minimum circuit ampacity on this. And so, that's where it's going to be kind of a little bit out of context, because you could have a minimum 30 and say like, minimum circuit ampacity of like 24 amps. And then, you have your maximum at 40, it could be that same 24 amps. So you can do both of those with number 12 gauge THHN. And so as long as your terminals are 75 degrees C, I don't want to steer anybody wrong, because on the exam, if the terminals are unknown, you have to go off 110 14C1 and use the 60 degree C column. But if the terminals are known and they're 75 degrees C, in this case, just let's just say the minimum circuit ampacity is 24 amps, you could use a number 12 and you could put on a 30, or you could use a number 12, you could put on a 40, or you could use a number 12 and you could put on a 20. But if you put a 20 on there and you nuisance trip, then that's because you exceeded the minimum. And that's fine. You can exceed the minimum if you want, but you're possibly going to get that nuisance trip.
Yeah, I did the calculation. It's 25.25 amps. If the condenser motor was 1 amp, then you could use a number 12. In this case, you'd need a number 10.
Gotcha. Yeah, I was just using hypothetical, so I
Yeah,
mean,
I know. I was just giving them in case somebody calculates it, wants to know.
10-4. Gotcha.
Okay, now we go over to our welders, and uh, when we looked at our welders, we talked about this last week. And one of the things I said you're going to remember when you get into this, you want to remember 630.11a and 630.31b. Okay. So, or should I say 630.12, the conductors are 630.11, but 630.12 is overcurrent protection device, but we're still going to do the conductors and overcurrent device. And I said, you want to remember when you're dealing with non-motor generator and motor generator welders, you want to look at table 630.11a, and you're going to get that duty cycle. Then there'll be two columns, one for the non-motor and one for the motor, and then get your multiplier from there. And then what we're going to do is check the conductor and everything at 200%, because when you go look at 630.12a, it's going to tell you the overcurrent protection device, and listen to what it says: rated or set at not more than 200%. So that means I would drop down, doesn't it?
Yeah, Justin missed his little snarky comment there from the last slide, so he was all he was all mad. So
Well, you know, I, everybody's heard me state this. I look at that welder right there. That welder is what? It's an
utilization.
assembly.
He's all
Utilization equipment, but I
he's all
call it an
dang delay.
assembly.
He's like the slide changed right when he. I saw the comment come in, but you already changed the slide.
I can fix that.
Yeah,
But
he's
see, this is the same thing. I've got an AC unit there. I've got a welder there. I consider that an assembly. I don't consider that an outlet. Okay. And I dang sure don't consider the disconnecting means an outlet. Okay. Uh, if I considered that disconnecting means as an outlet, I might as well just go ahead and consider the circuit breaker at the panel an outlet, because it's a
yeah,
device, you
true.
know. And that's where there's going to, we're going to see in the 2026 code come out, Don Gennari, Mr. Research, he submitted a proposal. Supposedly it was he we were going to learn, it was going to get clarified. Well, he submitted a change to an outlet, and they basically just rejected it. And then the only reason I happened to see it, because they referred it over to a receptacle outlet. And
Right,
basically, what they were telling you is, like the receptacle outlet, that's your box right there. That's the outlet, the box. It's not the point inside it,
right.
And that's why when you go look at Article 314, the very first word in that article is outlet. And then when you go down and you start picking up sizing it, it says an outlet. And it says outlet is size based on uh, 314.16 B1 through B5. And then if I'm going to look at the dimensions of the outlet, it literally says you got dimension of an outlet in 314.24. How do you have dimensions for a point? You know,
Well,
that's the
yeah,
box.
and I think Justin brings up a good point too, because like if you're just sitting there saying the disconnects and outlet, the load side terminals, then you have like the terminals that go to, now you start having multiple outlets. Like you could basically say there's three outlets in the circuit now. And
Sure.
it's like there's only, is there only supposed to be one? Is there supposed to be less than one? And to me, honestly, Justin, if you'll find this interesting, I went to every single journeyman I could find, and I explained the situation to them, and every single time they're like, "There's no outlet."
Yeah,
I
that's right.
mean, there might be have to be an outlet, but per definition, but like nobody's seeing it that
Well,
asked yet.
I'll say this. I have my reasons why I think there's no outlet. Okay, and I give them reasons based on what the code says. When it first started, they were arguing with me, telling me it was at the disconnecting means on the load side, and I said, no, it isn't. I said that's a device, and then I told them go device. Well, they took about 3-4 hours, and then they come back and said it was at the equipment, and I went over that, explained why it couldn't be. And then all of a sudden, it's just where the wiring method connects to the utilization equipment. It's just free floating and infinite space. I mean, they've changed like 4 or 5 times,
Mm-hmm.
every time I've argued a point. And, uh, and if the code making panel thinks there's an outlet, hey, that's fine. Where is it? You know,
Yeah.
so I submitted a proposal and I wanted them to clarify where that outlet location was. If they say there's no outlet, the debate's over.
True.
Okay, now let's get
Sorry.
back on this.
Sorry for interrupting the lesson.
Okay, so we got a 68 amp welder, and you're going to see we got a 50% duty cycle with 75 degree C connections. Everything's in the illustration. So in step one, we're just going to go ahead and put 68 amps. And then I'm going to look over and I'm doing a non-motor generator type. And I'm going to look at table 630.11a. And I'm going to come over to the left-hand side of that table and pick up my duty cycle, which is 50%. Come right across to get my multiplier here for non-motor generator. And it'll tell you it's 71%. So I'll take 68 amps at 71%, gives me 48.28 amps. And I'm going to size the conductor on 75 degrees C terminals. I'll look at table 310.16. The next size above that's 50 amps, which is a number 8. Okay. So now I'm going to look at doing it based on the multiplier and for sizing the overcurrent protection device in 630.12a. And when you go over there, it's going to tell you take a multiplier at 200%. Now, I want everybody to listen to what it says because I've said this over and over. It says each welder shall have overcurrent protection, and then it says rated or set at not more than. So that means it has to be equal to or it can't be more than. So that means I'm going to drop down, which falls into that rule of thumb once again if I'm above 125%. So I take the 68 amps at 200%. That gives me 136 amps. The next size below that's 125 amp overcurrent protection device. So now I'm going to cross check this and see if I need to, if I can protect the conductors at a lower rating. So you could say putting 100 amp instead of 125 amp here. So if I take the 50 amp conductors at 200%, that gives me 100 amps, which is a 100 amp overcurrent protection device. Okay, so there's 2 ways to do it. Or I could just say this: I could just take 68 amps at 200% and put 125 amp overcurrent device on it. I could do it that way also. Okay, either way is going to be correct, but we're going to protect the conductors here, and we did it based on the amperage of the conductors at 200%. Okay, now here's one I'm just showing what I talked about. I'm just going to do it 200% and just size the overcurrent device. I'm not even going to do the amperage for the conductor or anything. So I have 76 amps, and I'm doing a motor generator type here, and I'm going to have a 90% duty cycle. So I look in the left-hand column at 630.11a, pick up 90%, come across it, tells you take it at 96%. Now, this is what I'm going to use with the duty cycle if I'm going to take and do the conductor. Okay, but now if I'm not going to do the conductor, I can just look at the welders in 630.12a and just take it at 200%. Okay, so I showed you 2 ways here to check and size the overcurrent protection device. So I'm going to take the 76 amps at 200%, that gives me 152 amps. I look at table 240.68 for my standard ampere ratings. The next size below that's 150 amp overcurrent protection device. Okay.
Right.
Now I'm going to do a resistance, and I'm going to do it with the full calculation with the amperage and everything. So this one here, if you're doing resistance welders, you're in part 3. Okay, so you're going to be looking at table 630.31a when I'm going to do it based on the duty cycle. And then for my overcurrent protection device, I'll look at 630.32a, and it's going to tell you there to take it at 300%. So remember, non-motor and generator type arc welders, you're going to take and do it at 200%. A resistance welder, you're going to do it at 300%. Okay. So looking at this, I've got a resistance welder that's 91 amps, and I've got a 40% duty cycle. So if I look at table 630.31A, pick up 40%, it's going to tell me it has a 63% multiplier here. So I'll take the 91 amps times 63% will give me 57.33 amps. We got 75 degree C terminals. I'll look at table 310.16, come down. The next size above that is 65 amps, which is a number 6 conductor. Okay? So now I've already said, based on 630.32A, I can take it at 300%. So I'll take the 91 amps for the welder at 300%, gives me 273 amps. It says that the rating or setting cannot exceed it. So I'm going to drop down, which is a 250 amp. Now, let's see what the difference is here. I had a number 6, 65 amps, take it at 300%, gives me 195 amps. I drop down to 175. That's quite a bit of difference there from 175 to a 250 amp overcurrent device. So
Right.
it might be a good idea to learn this calculation, because if they're asking you for what the minimum size is on the test, guess what? You're going to be looking at 175 amp.
Right.
Okay? So those are your ways of going in calculating this for non-motor, motor, and resistance type arc welders. Okay?
Right.
Now, this one is where we're going to be looking at my remote control signaling and power limited circuits here. And basically you got your control circuits here inside the controller, and we're just cross-referencing, making sure that this is correct. So I'm going to look over, you're going to, those are looking through their code book, look at 430.72B2. And when you get over there, you're going to see the table that's going to be at the on that page. And you're going to see it's got notes in there that's going to refer you down. And you're going to see for this particular one, it's going to refer you to note 2. And it's going to tell you it's based on 60 degree C conductors, but it's going to tell you to look at table 310.17. And just remember this. These are control circuits, conductors that are inside the enclosure. That means it's in free air space. That's what table 310.17 is. So if I look at a number 14 conductor and I go over and I pick up table 310.16, it's going to tell you it's good for 25 amps. Okay? But now when you're looking down at your note 2, it tells you it's based on what? 400%. So if I take 25% at 400%, it's going to tell you it's a 100 amp overcurrent device. And then if I come over and I look at column B in that table, and you're picking up your conductors here, it says conductors within the enclosure. And if I come down and pick it up for number 14, what does it say? 100 amp.
Wow.
Isn't that amazing?
That's
so
crazy.
This is just proving it to you. Everything I tell you is true.
Welcome in, John Ayres, Wika
Hey,
in the
John.
house, sir. Awesome. Thanks for joining tonight.
Yeah, thank you, brother. Appreciate it. All right. Now, this is where you're going to see the control conductors running remote from the enclosure, and you're going over here to like a start and stop station here that's remote. Okay. Now, if you look at this, you're going to look at note 3 because they're remote, and it's going to tell you use the 60 degree C conductors, but it's going to tell you it's table 310.16 because those were run in what? A conduit. Okay. So if you go over and look at table 310.16 for your 60 degree C column, it's going to tell you it's good at 20 amps. You take that 20 amps and then you base it on the overcurrent protection device. Okay. So I've got a 15 amp overcurrent device, and you take that at 300%, that gives you 45 amps. And if I go over and look at column C, conductors extend beyond the enclosure, and pick up number 14, come across, what does it say? 45 amps.
Right.
Isn't that amazing? So that proves everything we were showing there. Now, looking at this one, I've got a transformer here. Okay. Now, what we want to do here is we're going to go over and we're going to look at the table here. Okay. So we're going to go over and look at table 450.3b. And if I have a current that's more than 2 amps but less than 9 amps, it tells you on that transformer to take it at what? 167%.
Right.
Okay. Now, if the current was 9 amps or more, you take it at 125%. And if it was less than 2 amperes, you take it at 300%. Okay.
Yep.
But here, we're going to figure out what the amperage is for that transformer. And this is a single phase transformer, 240 volts. So all I'm going to be, or 480 volts, I'm sorry. And we're going to take the 2200 VA, divide it by 480. That's going to give me 4.5 amps. I go over, look at table 450.3b. It's going to tell you it's less than 9 amps, but more than 2 amps to take it 167%. That'll give me 7.5. Now you'll notice looking in the table there, there's no superscript 1 there. So since there's not a superscript 1 there on that percentage, that means I'm going to drop down to the next standard size, which is a 6 amp overcurrent protection device.
Gotcha.
Okay.
All right.
Now, here's another one. I've got another control transformer here, and I'm going to be looking here at sizing these, sizing this overcurrent protection device. All right. Now, as I look at this, you're going to need to go over and you're going to look at table 310.16, and I'll show you why here. I'm going to prove a point here. All right. Now, if I go over and I pick up my number 10 conductors and I'm terminating at 75 degrees C, it's going to tell you those number 10 conductors are good for what? 35 amps. Okay.
Right.
And you'll see down in the bottom right-hand side of the illustration there, we're telling you our control conductors are number 10. Okay. So I'm going to get the ratio of the transformer, then multiply it by 35 amps, which is going to give me 17.5 amps. And then I'm going to be looking here in the controller here. You see I'm checking my fuse sizes here, and 17.5, I'm going to drop down the next standard size, which is a 15 amp overcurrent protection device.
Right.
Okay. So hopefully everybody has followed along with this and see all the different ways to go about dealing with these control conductors and how you're set up and determine the size for the overcurrent protection device now.
And if you guys like this content, just make sure and subscribe to the channel and tell your aunt, your uncle, your cousin, your grandma, your baby sister, everybody to subscribe to our channel so we can hit 1,000 this summer.
Yeah, we appreciate if y'all do that. That, you know, we're trying to put out, you know, the best content that we can. And when you get over and look, you know, we're going to do a grounding and bonding series where I'm going to go through all that. But we'll probably have Mike Barr on here pretty soon. And then
nice.
I think I'm going to get Dad to come in and do one and explain about purge and pressurized systems. Everybody seemed to be interested in that. So,
dude, he still owes me one. He still owes me one on what was that one we were gonna do? Tiebreakers.
Oh yeah, that's the one we're gonna have him do. We're gonna have him do tiebreakers. That's what it was.
Nice. Yep.
Okay, now this one's very easy. This is just a quick one. You go look at 760.43 where we're dealing with our fire alarm circuits. The information's already given to you. We just put this in, so you know there's no calculation. All you're going to do when you go over and look at it, it's going to tell you number 18 is good for 7 amps and number 16 is good for 10 amps. Therefore, once you know that, you got 7 amps, drop down the next standard size. That's a 6 amp overcurrent protection device. A 10 lines up, so you got a 10 amp overcurrent protection device. Okay?
So I just want to do a big shout out to all the NISAT guys that are joining us. I'm a NISAT too. A lot of those 760 references, you really have to pay attention to the ampacity When you go do your NISAT test, they really quiz you on that ampacity. They really want to know that you know how to calculate that. So that's a
Good.
good illustration, James. I like that one.
Yeah, that is a good looking illustration. They redrew everything. They literally came in. You can't see it till it's blown up, but everything that's on that control panel, that's just like you would see the control panel with all the buttons, what they're named, and all of that. I mean, they really did a hell of a job on it, in my opinion.
Yeah, that's kind of a wimpy panel, but I'm not I'm not gonna bomb on your wimpy panel, but it's all good.
That's an awesome panel. You know what the hell you're talking about.
I'm just kidding. I'm just joking.
All right. Now, the next one that we're going to look at is where we're going to get in and we're going to look at circuits at size of my overcurrent protection device. It's over 1,000 volts.
That's awesome, John. Thanks for joining us and checking out all our stuff.
Oh yeah, we definitely appreciate it. And when you get over and you look at this in 240.101A, they actually that got moved in the next cycle. Okay, so we'll get. I'm not going to get too much into that because I think, if I'm not mistaken, I think that moved over in 245.27. I think it is.
Okay.
I think that's where it moved because that's where they created a new one that talks about overcurrent protection for systems rated over 1,000 volts. And
Gotcha.
I think the new one's 245.27A, if I'm not mistaken. But when you go in, you pick this up in the 2020, it's going to tell you when you're uh, sizing this that you're going to take it at 600% when you're sizing the circuit breaker for that long time trip element. So I'm just going to take the 200 amps at 600%, and it's going to tell me that setting's going to be 1,200 amps. Now, when I get over here to the next one, which is going to deal with your fuses, it's going to tell you to take it at 300%. So I'll
Right.
take the 200 amps at 300%. Now the fuse rating is going to be 600 amps. Okay?
Okay.
And I think that about wrapped all of that up. So
Nice.
that gets us through sizing all the overcurrent protection devices. And now what we're going to get into is looking at doing our residential. Now, this is what you want to remember when you're getting into residential, and this is the way that we do it. We got 6 groups. You got your general lighting and small appliance and laundry loads. Okay, that's one group we're going to do right off the bat. Then you're going to get into is removing all your additional loads. So basically, think of it this way: I want to get my cooking equipment loads done. Then I want to get my dryer load done. Then I want to get the largest between the heating and AC. And then everything else that's left goes in the fixed appliance load. And then your 6th one is your largest motor load. Okay.
Nice.
Now, one thing I want to point out, when you get to the 2023 NEC, what you're going to get into is they made a change here. Now, when I remember when this was being asked of me, they said, well, what do I do if I have electrical vehicle there, service equipment? So where does it go? I said, well, right now, I said it goes into the fixed appliance load because there was no other place to put it. And they hadn't given at that point any place for you to take and have an amperage or anything that you're supposed to do. Well, now in this coming cycle, they did do that in 2023. Right. So what's going to happen is, and we're going to update the illustration, or we already have. For 2023, there will be 7 groups. So it'll be one of the loads that you'll remove from the fixed appliance load. Okay?
You know what I'd be interested to know, James, if you do the calculation the way that you said, like the old way, and then do it with the new way, if you come up with different numbers.
I don't know. We didn't really get into that because we just sort of kept the the calculation the same. We didn't get into the electrical vehicle. We didn't even put it in the calculation. We just sort of taught it that way. And now that it's that way, eh, they pretty much have come in and they want you to take now and they want to put that in as one of the separate calculations, and you're going to calculate that and add that load in. So we're going to retool, and we're going to not only put it in for residential, we're also going to put it in for the commercial.
So I guess your numbers would come out different because you're looking at if you're in with that fixed appliance load, then you're doing that as a demand, and then if you have it as a separate step, then you're going to actually have a higher demand, right?
I would, I, I'm not so sure it'll change a ton when you get to residential, but when you get to commercial, it will.
Okay.
And the reason it will on commercial is because when you go to some commercial buildings, they got 5 or 6 of them out there.
Oh,
And
dude, I'm on a building that's got 20 plus.
yeah, and that's why I'm saying when you start looking at that will start to change. So those are things that we need to look at when we get into this, and that's why I'm going to do uh, uh, here in 2023. I'll probably do it next year or later at the end of this year. I'm going to show a calculation, full calculation, adding all them loads in, so everybody knows what to do.
Right.
Okay. Now, based on that, knowing we got 6 loads based on the 2020, let's just look at doing uh, a calculation here uh, uh, for the general riding and small appliance and laundry loads. Now, I've got a 2,800 square foot dwelling unit, and if you go over and you pick up 220.14J, you're going to pick that up, and and let me say this, in the 2023, you're going to see that change also. That section has changed. Okay? So
Okay.
that's why we're going to have to do a new 2023 because of all the section changes. Now,
Right.
in the 2020, it tells you to take that at 3 VA per square foot, okay, for a dwelling unit. So I take 2,800 square foot at 3 VA, gives me 8,400 square foot. Then I go look at 220.52A. You have to have at least 2 small appliance circuits, and they're required to be taken at 1,500 VA each. So that'll give you 3,000 VA, and then you have to have in 220.52B at least 1 laundry load circuit there, and it tells you also take it at 1,500 VA. So you just add all of those up, that gives you 12,900 VA. Okay, that's about as simple as I can tell you. Just remember, 2 small appliance circuits, you got to have that, and 1 laundry load, and then know the square footage. Take it at 3 VA, total them all up, and you've got your VA. Okay.
I thought I talked to you, James, about taking my house as your examples for your calculations, but
Well, sure.
it's all right.
You
I'm like code times 3 over here, so
you may be in a bigger house if they tell you they got 3 small appliance circuits. Now it's 4,500 VA.
yeah,
I've seen
yeah.
some houses they got 2 different laundry areas. Now you got 3,000 VA.
Oh yeah,
Okay, so it just depends
yeah.
on the question.
I agree.
And then after you do that, then you look at table 220.42, and it tells you take the first 3,000 at 3,000 VA, anything that's left there up to 120,000, which would be anything over 117,000. So in this case, I'm nowhere near that. It tells you to take it at 35%. So I'll take the 9,900 VA at 35%. That'll give me 3,465 VA. Total it up, and we've got our first demand load, which is 6,465 VA. Okay, so there's demand load 1. Everybody with me on that? I
Yep.
did my first calculation in order to help me do a full residential calculation. All right.
And just to let everyone know, if you're out there and you're doing these calculations and you get lost in any of the steps, feel free to say, hey, you know what, step 4, I missed it, or I didn't understand what was going on. You know, we'll have no problems explaining it to you. And nothing is better from my standpoint than me going into that test and being able to confidently answer questions. And so that's what I appreciate from you, James. When I went to take my NISAT 2, I crushed it just because everything was just right off the top of my head. I was able to just do every calculation like nothing. Didn't even
Sure.
phase me.
And that's the thing, repetition. And
Yep.
it's just like right here. You've got uh, an exercise problem, and you've got all the blanks you can fill in and everything. It literally is step by step. And I will say this: when we get the learning management system up, and I got all this working and everything, you'll literally be able to go in online, and you can take and just click on them blanks and fill in the values, and then I'll have the answer key below, and you can sit there and work it. Now, if you're out in the field, for instance, and you're trying to determine something, these are forms. They're just like having a form at your fingertips. You can just go in, plug in the values, look at the sections and everything, and you can figure it out right on the job. Okay? And this one here, we tell you we got 3,500 square foot dwelling unit. We've got 2 small appliance branch circuits and 1 laundry circuit. I've already set it up for you and total it all up and get what your total demand is. Just remember the first 3,000 VA is taken at 100%. Everything else is taken at 35% up to 117,000.
Nice.
Once you get over that, then you add 25.
Thanks a
Oh,
lot, Danny. I appreciate you over on the Facebook side. I'm glad he understood it. So he said clearly explained.
well, thank you, Danny. You know, after 35 years, I should have picked up a trick or two.
Yeah.
So, I mean, I've put a lot of time on this stuff learning, and you know, you just sort of get better at it as you do it more and more. And you know, a lot of it is people asking questions, and you
Right.
start understanding what what they have trouble understanding, and it makes it easier to for any instructor to teach. The more experience you have, the better you are. I don't care what anybody says. All right, now let's take a look at this. Now, I'm going to show you, we're going to go through quite a few calculations where we're dealing with our cooking equipment, folks. Okay? Now, this first one, we're going to tell you we have a 12 kW and a 10 kW. Okay? Now, what you get into here is if you look at column C, this is going to be probably the one you're going to use most, where you're not over 12. Now, once I get over 12, then we're going to do some other things with the notes. But columns 1, 2, and 3, they're very specific. So here I got a 10 and 12. I'm not over 12 kW. So I pick up 2 units, come across it, tells you it's good for what? 11 kVA. Okay?
Yep.
But now, if I was below 8 and 3/4, now I've got a different problem. I could have an 8 kW. Now I got 2 different ones. Now I'm going to be looking at using some notes here. Okay?
Right.
So I'm just sort of showing you the column. If you have number of units and they all fall within these certain columns, just come across and it's going to tell you the kVA. Okay? So
Right.
like this one, everybody should get this. It's a 10 kW. You're going to come across one unit, you should put 8 kVA here. Okay? It's 8,000 VA. It's a simple one. All right?
Right.
Now, let's look at this. And now I've got a 2.5 kVA. Now, if I look in column 8, that's less than 3.5 kVA. Okay?
It's a 2.5 kW. Hey, Justin has a question. Just hold your question, Justin, until we get done with the lesson, and then we'll cover it. So I'm not ignoring you. We just want to get through.
Okay. Now, if you look at this, I want you to look at the table. And if you look at the top of that table right there, it says demand factor, and it says it's got a percentage sign, and it also says C notes. Okay.
Right.
Column C didn't have percentage there. So these 2 columns here, these are my percentages I'm going to apply to whatever that kW rating is. So I had a 2.5 kW rating, take it at 80%, that's going to give you 2 kVA demand load. Okay,
Right.
so take it at 1,000, you got 2,000 VA there. Very simple.
Right.
Okay,
Yep.
now this one here, I'm showing you two ranges here at 3 kW. Well, it's less than 3.5. I come down and I pick up 2. It tells me take it at 75% there. Okay, so I've got 2 of them, so it'd be 3 kW times 2, which is 6, and then you're taking it 75%. That's going to be your demand load. Okay,
Right.
now here's one at 8.5. Okay, it's at 8.75, 3.5 to 8.75, 8.5. That's below it. I've got one unit come down, pick up my number of appliances in the left-hand corners. One come across, tells you take it at 80%. So I'll take the 8.5 kW at 80% is 6.8 kVA or 6,800 VA. Very simple.
Yep.
All right. And then here I've got an 8.75 that still falls within that range. And I come across one unit, you're going to take it at 80%, and there's your kW rate. Okay. Or then take it at 1,000, gives you your VA. All right. And I want to point one other thing out. When we get there and we start doing our full calculations, one of the things that you're going to see is we're going to put everything in VA. The reason we put it in VA is because when you divide by the voltage, that's going to give you your amperage. Okay?
Right.
Now, let's look here. Now, I've got a 25 kW rating here. All right? Now, that I'm going to be looking in column C because I'm over 12 kW. And then it's going to tell me I'm over 12 kW, so I'm going to look at the notes down here, okay? And if I go look at note 1, it says over 12 kW through what? 27. And you can do this where they're all of the same rating, okay?
Right.
When I get to where they're in equal ratings, then I'm going to look at note 2, all right? So what does it say? Let's just read what it says, and then I'll explain everything I'm doing here. Now it says, for ranges individually rated more than 12 kW, but not more than 27 kW, the maximum demand in column C shall be increased. Now listen to this, and you're going to see this a lot, so get used to this. 5% for each additional kilowatt rating. Okay? So if I look at this and I take 25 kW, I'm going to subtract that by 12 because 12 is already taken up here up to 12 kW in column C. That's going to give me 13 kW. Sorry, I should have moved that 13 kW down one. So I take the 13 kW for each additional kilowatt, which is 5%, gives me 65%. So basically that's 100% of the load. So I'm going to take 100% plus 65. That's 165% I'm adding for each additional load. So then I'm going to look, I have one range that I did for the 12 kW. Come across it, tells you it's rated at 8 kW in column C. Okay, so I take the 8 kW at 165%, and that'll give me 13.2 kVA or 13,200 VA. Okay.
Yeah, and one thing I want to just tell everyone too, the thing I like about James, the way he sets up this stuff, he's not just dropping the full calculation on you right away. What he's doing here is he's giving you the tools. He's showing you, so this is kind of your homework too, because you guys should be prepared when this comes up for the full calculation. You should know these steps and be able to just whiz it like a piece of cake. So that's the one thing I always liked about your stuff, James.
Well, thank you. And this is the same one. I'm over 12 kW, so I got a 16 kW range. I'm taking 16 kW, and I subtract it by the 12 because it's rated up to 12 kW range. That's going to give me 4 kW. Then I take that's my additional uh, um, for each additional watt that I have there. I'm going to take that at 5%. And then I have one unit. Once again, I'll take 8 kW, and I can tell you it's going to be multiplied at 120%. Okay. Now, the next one, let's look. I've got a 12, 14, and 20. All right. These are not of all the same rating. So since they're not of the same rating, I'm going to look at note 2, which I was talking about which is over 8 3/4 through 27 of unequal ratings. Okay. So basically, what that's telling me here is I have to take and I've got to get an average rating of each one of those. So I'm going to add up the 12, 14, and 20 kW, which is going to give me 46 kW. And then I'm going to drop down, since I have 3 units, I'm going to divide it by 3, which is going to give me 15.3. So I'm just going to round down to 15 kW. Okay. Now, once I round down to 15 kW, then I'm going to subtract it by what? The 12 kW, just like I did before. And that's going to give me 3 kW. Take that at 5% for each additional kilowatt. That's going to give me 15%. And then if I go over and I pick up 3 appliances and I look at column C come down, it's going to tell you it's good at what? 14 kW. So I'll take the 14 kW at 100% of the load plus the 15% for each additional kilowatt, and that's going to give me 16.1 kVA or 16,100 VA for the 3 pieces of cooking equipment. Okay? Nice. And then here, same thing, 12, 16, 24. Add them all up, get an average rating, subtract it by 12, then you take each additional kilowatt rating that's there at 5%, and then add it up based on those 3 ranges, which again would be 14 kW based on column C. Okay. Now, here's a good one of unequal ratings, and this is where you want to get into this and look at note 4. Now, I have a 12 kW cooktop, and I got 2 6 kW ovens here. I'm going to do pretty much the exact same thing. I'm going to add them up, and remember, I'm treating this as one unit because if you look, I'm telling you I have a branch circuit here. I'm feeding all of this with one branch circuit, where the other one, they were 3 individuals. Okay? So since this is one circuit, I'm going to add it all together and subtract it by what? 12 again. That gives me 12 kW. That's your additional kilowatt for each one. That gives you 60%. So then I look at, because it's on one circuit, we're going to treat it as one range here. We're just going to come across, pick up the 8 kW at 160%, and that's going to give me 12.8 kVA or 12,800 VA. Now, when you're taking the test, if they tell you what is the branch circuit demand load, may put something like this, you know it's on one circuit. It's not on 3 individual like I was doing back here.
Right.
See, I've got 3 individual pieces of cooking equipment. Here, we're telling you it's on a branch circuit. And then if you look at the illustration, look at that illustration and look at this one. Right. 3 individuals. This one here is on one circuit.
Yep.
See that?
And it's like, yep.
So you do the same thing here. Add all of those up, then subtract it by 12. That's your additional kilowatt. Take it at 5%, and then take the 8 kVA, because it's considered one, at whatever the additional kilowatt is, and that'll give you your total load.
Nice. Okay?
Now, this gets very simple, because when you go over and you look at your dryer load, basically what it's going to tell you here is when you look at your dryer load, one thing that we definitely know here is that it has to be rated at what? 5,000 watts.
Right.
Okay? So no matter what, I'm going to have to kick this up to 5 kW. And if you go look at 220.54, it's going to tell you that. Now, if I have 1 to 4 dryers, you look at table 220.54 and you're going to take it at 100%. Once you start getting above that level, then there's demand factors that are going to be applied there for your percentage. So in this case, I've got a 4 kW dryer. I know I have to kick it up to at least 5 kW. And I have 1 or fewer, so I'm going to take it at 100%, and that's going to tell me the demand load here for the dryer is 5 kVA or 5,000 VA.
Dude, if you got less than 4 dryers in your house, you're weak.
Well, here's one. I'm going to show one where I have 5 dryers. And each one of them are 8,000 VA each. So it exceeds the 5,000 VA. Now, if I look in table 220.54 and I pick up 5 dryers, what does it tell me take it at? 85%.
Yeah.
So I'll just take the 8,000 times my 5 dryers, take it at 85%, and it's going to tell you the VA load there's 34,000 VA.
All right.
Very simple.
Cool.
Now, what I want to point out is I'm removing loads right now. Okay? So I've done the cooking equipment load and I've done the dryer load. Okay? Now, I look at this, I got a 5 kW driver. Only have 2.
Yeah,
Well, you
John.
also had the general lighting load.
That's
Oh,
that's John Harris on my joke where I said if you don't have 4 dryers in your house, you're lame.
okay.
But I was just joking, John. I only have 2 in my house.
I've got 4.
Okay.
No, I'm just kidding.
Yeah.
All right.
I have one broken one working one.
Yeah. We're, I don't know what's going on. I think there's something wrong with the dryer, but we got somebody coming to look at it.
So you got one working one broken one too.
Yeah. The washer's working, the dryer's having problems. All right. So this in here is 5.5 kW. That's 5,500 VA. You take that at what? 100%. Everybody should be able to do that calculation with no problem. It's only one. It's 4 or less, so you take it at 100%. And to even help you, right there in the middle of the illustration where it says formula requirements, we even have the percentages there for you to look at. All right. Now, there'll be only one other load I'm going to remove from this, but I'm going to go ahead and show now how to do the fixed appliance. So the only other load that's left is the largest between the heating and AC. Okay?
Right.
And that's called a non-coincident load in 220.61. We'll look at that after we finish this. But everything else that's left goes where? Here in the fixed appliance. I don't care if it's 240, 120, whatever. It all goes here. Now, when you look at this, we have a 6,000 VA AC unit, 10,000 VA heating unit, a 5,000 VA water heater, 8,000 VA oven, 8,500 VA cooktop, 2,600 VA water pump. And those are all 240 volt loads. And then you look at your other 240 volt loads here. 5,000 VA dryer and an 800 VA blower motor. Now, what I do here is I look at what gets removed from here. Well, we already did the dryer, didn't we?
Yeah.
Okay, dryer load goes. Okay, we did cooking equipment, it goes, right? There's a cooktop and oven. All right, now there's only 2 other things that are left here. And that's my non-coincident load between my heating and AC load. So those will drop. Everything else that's left there is going to be in the fixed appliance load. Okay? So when I come over here and I start to look at doing this, let's remove the loads. I'm removing the heating, AC, dryer, and cooking equipment loads. Everybody see that?
Yeah.
This is how you want to learn to do full calculations. What goes where and what stays where. So we're removing these loads from doing the fixed appliance load. So then I'm just going to take all them loads that were left and add them up, and then you go look at 220.53, and what it says here, when you pick this up, this is a demand factor of 75% that's applied here. And as you go in and read this, right below it, you're going to see, and this is something I want to point out also to everybody else. When you go look in the 2023 NEC, you're going to see they've got a new item 5 there that says electrical vehicle supply equipment. That'll be one of the loads that will be taken off here. We're going to remove that load from the fixed appliance load. Okay? So everything else that's left here, and if you have 3 or less, then you're going to take it at 100%. But I have 4 or more, so I'm going to take it at 75% per 220.53. So I'll take the 13,200 VA at 75%, and then there's my demand load for the fixed appliance load of 9,900 VA. Okay?
Nice.
Now,
All right.
right here, I'm looking at this illustration. Okay? I'm automatically know AC, heating, oven, cooktop, and dryer load do not go. Everything else left is there in the fixed appliance load when you do this calculation. I have 4 more, so I'm going to take it at 75% to get that total load. All right. And then you come to the last one before we get to the largest motor load. All right. I've got a 10 kW heating unit and a 5.5 kW air conditioning unit load. Now, when you look at this and you pick up 220.60, it says if it is unlikely that 2 or more non-coincident loads will be used simultaneously, using only the largest loads that will be used at one time for calculating the total load for the feeder or service shall be permitted. So these are not going to be operating at the same time. They're non-coincident. So whichever is the largest between the two, we're going to take and we're going to drop a load. So here I'm going to drop the AC load. It's the smallest load. It's 5.5 kVA, and the heating load is 10,000 kVA. So I would take this and I'd just put 10,000 VA on to my steps here when we get to the full calculations. All right. Now you look here. You got a 20 kW heating unit and a 2.5 kW AC unit. Pretty easy to say here which non-coincident load's the largest, and that's going to be your heating load. Okay? And
yeah, I wanted to do a little thing for John Harris out there that we haven't gotten to the EVSE yet because he's asking if the EVSE would be 100% demand, and I'm just basically telling him that it'll be based on the continuous demand, whatever they came up with for that multiplier in 2023. So that will be the part.
Let me answer that. The
Do you want?
EVSE, what you're getting into, the 125%, that's for the branch circuit. That's totally different than dealing with the full calculation here. Okay? And because we're setting this in and we're dealing with this right now in the fixed appliance load. Now, when you get in to the full calculation, especially commercial, if it's a continuous load, you have to take it at what? 125%. So you would have to add that on there. Okay? But that's something I want to take a little bit of a look at, because I look at it this way. People say, well, that's a motor load. Well, you could say that you want to take and calculate it like that. But when you're really getting into that, I don't look at it that way, because that is an assembly. It's not something that's separate. So I would look at that if all of them are being continuous, just like lighting loads. And if I could even have a receptacle, you're plugging something in that's individual going over that operates 3 hours or more. Those will be taken at 125%. But I'll go over all that when we get into commercial.
Okay.
Now, here's where our last load. Now, let's look at what we've done up to this point. We've done the general lighting and receptacle loads, which dealt with the small appliance in the laundry circuit. Okay, so we got those loads. That's 1. Then we did cooking equipment loads. That's 2. Then we did dryer loads. That was 3. Then we did the fixed appliance load. We put everything that's left in there. That's 4. And then we did the non-coincident load, which was the heating and AC load, which was 5. And now we've hit our 6th load, which is what? Largest motor. Okay? Yeah. That's what I want you to remember when you're studying for your test. Now, if I look at this, I've got a 3 horsepower, 230 volt single phase motor. Now, since it's single phase, I'm going to be looking at table 430.248. And if I go pick up my 3 horsepower for 230 volts, it's going to tell you it's good at 17 amps. So all I'm going to do and you can look at all these sections, they tie in here. You can be looking at a single motor, you're looking at 430.22. If I have multiple motors, I'm looking at 430.24 and selecting the largest one. Okay.
Right.
And basically, all I'm going to do is take every one of them motors at 100%, but the largest one, I have to add an additional 25% on that. So in this case, we're telling you the 17 amp was the largest motor. I'm going to take it at 25%, gives me 4.25 amps, and I'm going to add that additional on there. Now, if I just took the whole 17 amps at 125%, it would be 21.25 amps.
Right.
Okay. And the way to prove that is if I took 17 amps at 100%, that's 17 amps. You add the 4.25 on it, it's 21.25 amps.
Yep.
Okay.
So there's two different ways. If you guys want to do stuff different ways, you could do it two different ways.
Yeah. Basically, what I do is I just take, once I've done all the calculations and everything, I just add the 100. I just do it at 125%, and I'm done with it. That's the way I do it. But people say, "Well, how do you get the? You say 25%. Just put 125% on the largest motor, and you're done." So I'd have 21.25 amps. It's 240 volt, 120, 240 volt system. That'll give you 5100 VA. Then just add all the other motors up at 100% and you're done.
Nice.
Okay. So here's one here. We're showing you a 5 horsepower single phase 230 volt. Get the amperage, take it at 25%, and that'll give your amperage. Take it at 240 volts, and that'll give you your total load for your additional VA. Okay?
Yeah, and I just want to do a big kind of shout out to all the apprentices that want to like pass the test and want to just like know this stuff and be confident. James is giving you like the tools that you need to be able to pass the test, and you can try them live next week. So just learn what he's teaching this week, and then when he does the full calculation, see if you're right, see if you're wrong. You know, you have something to compare against, and it gives you that live situation, you know.
Sure. And like this, and I want to show, I just did this. This is 230 volts, but look at the next one. The next one, it could be that 115 volt motor is the largest,
right?
Instead of the 230 volt. See that? Yeah. So this is one that gives you here doing it at 120 volts instead of 240.
Yeah.
Okay.
Yeah.
And with that, my friends, that is going to get us done till next week, and